All right, Unit 4, Video 5, Correlation versus Causation. When there is a correlation, we are saying that as one variable changes, the other also changes, either positively or negatively. As you can see here, positive, as x goes up, y goes up. Negative, as x goes up, y goes down. Think of it as our linear equations we've graphed. Causation is a special correlation that means one variable directly caused a change in the other variable. A great example for causation has to do with calories. And when you work out, you burn more calories. The more active you are, the more calories you burn. So that's a great example of causation because, again, movement is causing calorie burn. All right, here's a visual display of correlation with positive and negative, so you can see what we're talking about, because we're talking about with scatter plots, basically. So correlation is positive when the values increase together, as you see here. Even here, even though it's a poor or low positive correlation, it's still going on in there. Correlation is negative when one value decreases as the other increases. So here, as x is increasing, y is decreasing. Even though it's a weak one or low, it's still in that. Same thing here, and there will be your negative. Here's just another visual representation of that so you can see that. Okay, so here's an example. A few years ago, a survey of employees found a strong positive correlation between studying an external course and sick days. So then the questions are, does this mean studying makes them sick? Sick people study a lot. Or did they lie about being sick to study more? At this point, we cannot tell. We don't have any data to represent that. But these are questions that come to the mind when you see these correlations. All right, so we're going to read the description, identify the variables in each situation, determine whether it describes a positive or negative correlation, and then explain whether the correlation is a result of causation. The example is, the owner of Hidden Valley is studying the relationship between the amount of snowfall in centimeters during the season and the number of visitors per season. The owner collected information about the amount of snowfall and the number of visitors for the past 20 seasons. After analyzing the data, the owner determined that seasons that have more snowfall tend to have more visitors. Okay, so the variables are the number of centimeters. I'm going to shorten that to number sign with cm for number of centimeters of snowfall, and then the number of visitors. Those are our two variables that we are comparing here. All right, so we found the greater number of centimeters, so it's highlighted there, have more visitors. So greater snowfall, greater visitors, so it has a positive correlation between the two. And then the last thing is, causation is possible, but unlikely that the amount of visitors affects the amount of snowfall during a season. However, it's also possible that other factors affect both variables. So we can't say for sure on causation. All right, same directions. For years, educational researchers have been looking to see what connections there are to high math and science grades. A survey was conducted that asked 150 students the number of extracurricular they are involved in, then went to look up those same students' math and science grades. The survey discovered that students who are involved in a greater number of extracurriculars tend to have a higher grade in their math and science courses. Okay, so the variables are the number of extracurriculars. So these are things they do besides school. Curriculars, I'm struggling with writing. And grades. Those are our two variables. We're going to look at how many extracurriculars they are in and what are the grades they received in these classes. So to determine correlation, we look at this part that I've highlighted. Students who are involved in a greater number of extracurriculars tend to have higher grades. So again, on this one, we have a positive correlation. And then again, causation is possible, but unknown which causes the other. So we would have to do more data, more research on this to determine if this truly was an example of causation, but right now we can't determine that. Okay, same directions. State Farm Auto Insurance constantly collects data in regards to accidents and age. They found out as age increases between 16 and 65, the number of accidents per 100 policyholders decreased. Okay, so my variables are ages and years, because we're looking at the different ages of these drivers, and the number of accidents. And we want the data of how many accidents someone in what age bracket are getting. So again, to determine correlation, I highlighted in yellow. It says, as age increases, accidents decreased. So this has a negative correlation. So even though we know that this is what's going on, causation is possible, but again, we can't say for sure, so it's just a possibility. All right, the other thing we have to talk about is correlation coefficient, which is known as R on your calculator. This measures the strength and the direction of a linear relationship between two variables. A number between -1 and 1 that indicates how well a regression equation truly represents data being examined. If it is close to 1 and -1, the model is considered a good fit. If it's close to 0, the model is not a good fit. If it is exactly 1 or -1, the model is a perfect fit with all data points lying on the line. If it is exactly 0, there is no linear relationship between the two variables. Okay, so I brought back that visual we used before because of these numbers down here that we didn't talk about previously, but these are correlation coefficients down here. That's what they're representing. So correlation greater than 0.8, so here's the 0.8 and the -0.8, is generally described as strong or high. So again, this is a strong or high correlation. A correlation that's less than 0.5, and that's where you're seeing this 0.3 and -0.3, is described as weak or low. Because we're getting weak, it's getting spotty where all the dots are. A positive correlation has a positive R value. So to see the positive, think of that positive slope that you're looking for. And a negative correlation has a negative, you notice the negatives down here, has a negative R value. Okay, but we're going to use the graphing calculator to find the correlation coefficient, because to do it by hand, it is very tedious and very long. So before your calculator would do this, you must turn on diagnostics. To do so, you need to press second and then 0. This opens the calculator's catalog. You're going to scroll down until you see, and it's in alphabetical order, diagnostics on. Press enter until the calculator says done. Now, you won't necessarily have to do that every single time, but since you don't own the calculator, the ones in the classroom anyway, we reset them for various purposes, so you may need to check this if you're doing it. And then last but not least, this is exactly the same way that you're finding the line of best fit. Once you have the diagnostics turned on and your data entered, press the Stat button, then scroll over to Calc, select number 4, line regression, AX plus B, and press enter. The correlation coefficient is the letter R.